Hello everyone. I, Dr. Meenal Nerkar, welcome you all to this session on Quicksort. In this video, we are going to learn about Quicksort working step by step, its implementation and analysis. Quicksort is an efficient comparison-based sorting algorithm that follows the divide and conquer approach just like the binary search. Quicksort works by selecting one element as a pivot element, partitioning the other elements into two subarrays according to whether they are less or greater than the pivot. The same process is then repeated recursively for left and right subarray. So if you observe over here, the algorithm for quicksort has three parts. One is nothing but the selection of the pivot. Second is nothing but partitioning the elements with respect to the pivot. And the third part is nothing but recursively apply the quicksort to the left and the right subarray. So in pivot selection, basically the pivot is an element to divide the given array. Good pivot reduces the recursion depth, making the sorting faster. We can select either the first, last, random, middle, or the median of first, last, and the middle elements as a pivot. Commonly, first and the last element is selected as a pivot element. Now, coming to the second part or the second step, in the partition, the elements in the array are getting partitioned with respect to the pivot in such a way that all the elements to its left are less and all the elements to its right are greater than that of the pivot element. So every partition places one element exactly where it belongs. So if you observe over here, the pivot element is placed at its proper position. Okay. Once the element is partitioned using the pivot, third step is performed. Apply in the third step, we are applying the quicksort method to the left side subarray and right side subarray recursively. And this recursive division persists until each subarray contains only a single element. Once the subarray consists of single elements, they are inherently sorted one. Now, once just now we have seen the theoretical part, the same thing is pictorially represented over here. The quicksort consists of three steps. The first step is nothing but the selection of the pivot element. Over here we are selecting the first element as a pivot element. Later on, the second step is nothing but what? Partitioning. So in the partitioning, we are fixing the position of the pivot element in such a way that all the elements to its left are less and all the elements to its right are greater. After that, we are giving recursive call to the quicksort function for the left side subarray and for the right side subarray. So this the process is now getting repeated. Okay. So again, from the left side subarray, the first element is picked as a pivot element, partition it, and then again control will come over here. So likewise, this process is repeated until the size of the subarray becomes 1, because when the size of the subarray becomes 1, this means there is no need of sorting. There is only one element and that is obviously be the sorted one. Now we will see one example. Over here we have already seen these three steps. So these three steps, how we are going to apply on for this algorithm, for this input. If the input is 8, 5, 2, 4, 11, 9, 22, so the first element is picked as a pivot element. With respect to this element only, we are going to partition the given array. So after partitioning, after applying the second step, if you see, all the elements to the left are less than that of the pivot element, and all the elements to the right are greater than that of the pivot. So pivot, the right side will contain the element 11, 9, 22. Now after this we are recursively calling the quick sort for the left side sub array. So from this sub array, we are picking the first element as a pivot element. So with respect to this element, we are partitioning the given array. So after partitioning, the left side will contain 2 element and right side will contain a 0 element. Now again over here, as there are more than one element, again we are picking the first element as a pivot element from the left side subarray, and with respect to this we are partitioning the element. So after partitioning, we are getting the left side is containing 0 and the right side is containing one element. As there is only one element in the array, so we stop the recursion. So this ensures the elements are already sorted. Then control will go to the right side of the array. So again from the right side sub array, first element is picked as a pivot element, and with respect to it partitioning is done. So after partitioning, we are getting a balanced partition. Left side is containing single element and right side is containing single element. So now over here, if you observe, all the elements are now sorted: 1, 2, then 4, after that 5, then 8, then 9, 11 and 22. So they are sorted 1. So this is how quicksort works. Now we will see the how the partitioning function works. So over here, as you have seen, we can select any element, pick any element as a pivot element. So in the partition function, we are picking the first element as the pivot element. So uh, before giving before this, we will see the quick sort. In the quick sort, basically the things that we are doing is we are giving call to the partition function if the size of the array is more than 1. Okay, so partition function is called from here. Then control will go to the partition function. Over here we are selecting the first element as a pivot element. So pivot is nothing but the 27, okay, for our example or in our case. Now we are making use of the 2 pointer. The low pointer will point to the start plus 1. So low pointer is pointing over here and high is pointing to the end. High is pointing over here. Now next, in next thing, we are iterating the loop. So while there are some elements in the given array, in that what we are doing is we go on incrementing the low pointer and we are going to decrement the high pointer, and this increment and decrement will continue until they cross each other. Okay, so over here see, while array of low, that is array of low is nothing but the 25 is getting compared with the 27. As 25 is less and our aim is to place all the smaller element to the left, we will simply increment the low pointer. So see here, low pointer is getting now incremented, I low plus plus. After that again we repeat the same process. Pivot element is getting compared with array of low. So as 53 is greater, so we stop incrementing the low pointer and we will go to the other pointer. So over here this loop, while loop continues until we come across the element which is less than that of the pivot element. Okay, so over here 44 is getting compared with 27. 44 is greater, so we will decrement the high pointer. Now again 43 is greater than that of the 27, decrement the high pointer. 89 is less, decrement the high pointer. 14, now 14 is not less than that of the pivot, so control will come out of this while loop, and low and high have not crossed each other, so we will simply swap the element. Okay, so element at the position low with the high. So over here, instead of low and high, what we are doing is, here it should be array of low is getting swapped with array of high. Elements are getting swapped over here. Okay, so now see, 14 will occupy this position, 53 will occupy this position, right? After that, again continue the same, as there are still some elements pending for the comparison. So again repeat the same process. We go on incrementing the low is incremented, it is pointing to 92. Now 92 is not great less than that of the 27, so we will stop incrementing the low and go to the other side, go to the this second while loop, decrement the high. As 18 is less than that of the 27, decrement the high. Now 50 is greater, so we stop, and now they have not crossed each other, so we will swap these two elements, 18 with 50. After swapping, repeat the same process. Now low is incremented. After incrementation of the low, 70 is greater, so we will stop over here, and after stopping we will simply go to the other side. So this high is now getting decremented, it will point to the 20. 20 is less, so decrement the high. 71 is greater, so decrement the high. After this, 52, decrement the high. 35 is also less than that of the 27, decrement the high. Now 65 is also greater, decrement the high. So now at this point, if you see, low and high, they crossed each other. Low is no more less than that of the high, so control will come out of this while loop, and over here we got the position where the pivot will be placed. So we are simply swapping a of high, array of high, with the pivot element. So after swapping, we will get this. So this is the pivot element, and the left side subarray will contain all the elements less than that of the 27, and right side will contain all the elements greater than that of the pivot element. So this partition function is return the partitioning position, or the position of the pivot element, and the position of the pivot element is there in the index high. So this high we are returning, so that return value we are collecting in the p becomes the partitioning position. So we are recursively given call to the quicksort for the left side subarray. So left side subarray uh, ranges from the start, this is the start, to the p minus 1. So this is nothing but the pivot position minus 1. Okay, and the right side array subarray ranges from pivot plus 1, this means this position, to the end is nothing but this position. So this is how the quicksort works. Now after this, we will come to the analysis part. So quicksort, best case as well as average case time complexity is of the order of big O of n log n. The time complexity as well as the space complexity of the quicksort, it depends on the selection of the pivot. So the best case occurs when the pivot is almost at the middle position or near, somewhat near to it. This ensures the splitting of the array